All right, so 7-4. This chapter 7 only has 5 sections, and chapter 8 only has 5 sections. It goes very, very quick. These first 2 chapters. We will take our first chapter exam next week. All right. Notice the end of this week, we're going to do our performance tasks in our chapter 7 review. We'll take our quiz today. Chapter 7, for all intents and purposes, will be completed by the end of this week. We'll just need the test. So, this is kind of an interesting little section. And I'm going to give you a diagrams on the board right before the test to make sure you can follow along with this. Remember, all quizzes you can use your notepads on, but the test you can't. But I'll give you this diagram. So it turns out that if I have a right triangle, and the thing we're going to look at today only works with right triangles. In a right triangle, the altitude to the hypotenuse of a right triangle divides the triangle into 2 triangles that are similar to the original triangle. So what that means, the altitude to the hypotenuse, that's going from the right angle side directly across. Remember, right angle opposite. So notice here, I've created 3 triangles. The original big one, this little one, and the medium side. We have a big, a little, and a small triangle. These 3 triangles are all similar to each other. Let's see how we can use that. Write a similarity statement. Can you write, what similarity statement can you write relating the 3 triangles in the diagram? So we want to write a similarity statement. So let's go ahead and separate these 3 triangles. Well, first, let's move this on over. Let's go ahead and make the big one. Pull that over. And that's triangle in blue. Q, R, P, and I'm going to denote that right angle. The next one, you have the smaller one. Q, S, P. There's the right angle there. And the medium one in green. Pull that on over. And we have our right angle here. That is S, R. So we have these 3 triangles. And put that theorem above states is that these are all similar to each other. So let's write our similarity statement. So we have triangle. I'm going to start with the right angle to make it nice and easy. Triangle PQR is similar to triangle. We went from the right angle to the smaller side first, and then to the hypotenuse. So it's similar to triangle SQP, which is similar to triangle SER. So all 3 of those triangles are similar. Questions on that item? For any 2 positive numbers, A and B, the geometric mean is the positive number x such that A over x equals x over b. What it turns out it is, geometric mean is the square root of the product of 2 numbers. The square root of the product of 2 numbers. Yeah. Okay? So think about this. When I cross multiply these to solve, I end up with x squared equals a times b. So x simply equals the square root of 8. So what is the geometric mean of 4 and 18? This is how I set each of these up. I'm going to drop my x and x's. And then take my two numbers. Do that. And put them here. And x times x is x squared equals 4 times 18. We'll just cross multiplying here. 4 times 18. 72. The square root both sides. So if I take the square root of 72, I get 8.5. Or in simplest radical form, I know the square root of 72 equals the square root of 36 times the square root of 2. So I can say 6 square root 2 is also an appropriate answer. So now we're going to use our geometric mean to solve a couple of these problems involving these right triangles. All right, so these are the two diagrams that I constantly refer back to. Okay? And I'll tell you a couple tricks to memorize them, but I know it's a little bit tricky. All right, so these are just corollaries to the theorem that states that the hypotenuse, the altitude to the hypotenuse of a right triangle creates three similar triangles. So these are some of the things we can use based on that. So it turns out that this altitude is the geometric mean of the two segments that it divides the hypotenuse. So the length of that altitude is the geometric mean of the two segments that divide the hypotenuse is divided into. Furthermore, this leg is the geometric mean of the segment that's closest to that leg, and then the length of the entire hypotenuse. Length of the entire hypotenuse. A little bit tricky, but when you're doing homework or any of these type of problems, have this out. Keep referring back to it. See if you can distinguish what you're looking for and what you have. And what you're looking for and what you have. All right, so let's look at these. All right, so the next one. On to the next page. Last two problems in these things. So let's go ahead and use these. I want to solve for x and y. So first, let's set this up. We have two types of problems to solve here. The first one, to solve for y. I said that the hypotenuse, right there, is the geometric mean of the segments that the hypotenuse is divided into by that. So we put 4 and 5. So we can cross multiply. And I get y squared equals And we square root both sides. Y equals 2 root 5, or in decimal form, 4.5. The other corollary that we're using is this leg, that x, is the geometric mean of the leg, the segment that's closest to it, the 4, and then the length of the entire hypotenuse. So now I'm going to cross multiply. X squared equals 36. Square root both sides. X equals 6. And like I said, before you have those memorized, just have these examples up in front of you so you can say, oh, I know which one. This matches this one, this matches that one. Okay? They can be a little tricky at first. All right, last problem on the notes. Woo. All right, so you're preparing for a robotics competition using the setup shown here. Points A, B, and C are located so that AB is 20 inches. AB is perpendicular to BC. And point D is located on AC, so that BD is perpendicular to AC. DC is 9 inches. You program your robot to move from A to D to pick up a plastic bottle. How far does the robot have to go? So I'm going to solve for this. Let's go ahead and pop this out so it looks a little bit clearer. All right. Draw this in. We have this is 20. This is 9. I want to solve for this one. So I need to figure out which one I'm going to use. Is this that first example? No, the first example would involve this altitude right here. So this is the second example that we went. So I'm going to set this up. We have the leg, which is the geometric mean. So 20. 20 can go there and there. And then we have the section that's closest to it, which is the x, and then the length of this entire thing. We have x plus 9. All right, so what I'm going to do is cross multiply. Make sure we keep those in parentheses. I get x squared plus 9x equals 400. I'm going to subtract the 400 over. And I get x squared plus 9x minus 400 equals 0. And this is what we were working on last week, right? Solving a quadratic. So I could use completing the square, I could use factoring, or I could use the quadratic formula. I always start by seeing if I can factor it first. Let's see if we can factor this. Right? And sometimes big numbers are tricky. Right? What I need is two numbers that multiply to negative 400, but add to 9. Okay. So what do I know? If they multiply to a negative number, I know this 9 down here has to be the difference between the two numbers. So I need to come up with factor pairs. With big numbers like 400, factor pairs can be a little bit challenging. Here's a trick. We know this came from up here, 20 times 20. Right? So I know this is 2 times 2 times 5. And then the other 20 is 2 times 2 times 5. So what I need to do is locate or figure out any combinations that will give me a difference of 9. Give me a difference of 9. So let's go ahead and look at these, taking these apart. What about 4? So our factor pairs. And then I'm going to do a little chart for the differences. So we have, let's start with the easiest ones. We have 1 and 400. That's a difference of 399. That's way too big. I know I'm not even close. So let's go a little bit bigger. What about 2 and 200? Difference of 198. Still way too big. I need a difference of 9. All right. What about 2, 4, 6, 8? And 20? Or not 8 and 20. That is 8 and 50. My bad. Too big. We're getting there. We have a difference of 42. What about 2, 4, 6, 8? What about 16 and 25? What's the difference between 16 and 25? 9. There is what I'm looking for. So one of these has to be positive and one has to be negative. So that's 16 and 25. Which one's the negative? The 16 to make that a positive number. So we factor this out. We have x minus 16. And then x plus 25 equals 0. What are my two solutions? You can take the opposite of each of these or use your zero product property. And I get x equals positive 16 or negative 25, the opposite of those two numbers. Our robot can't travel negative feet, so we're going to ignore the negative solution. And our answer is it inches or feet? It's in inches. Right? So the robot needs to travel 16 inches.